This pocket watch from the 1700s is by far the oldest timepiece I've worked on. Today's repair is going to be a little bit different. No, okay, a lot different. Not only does this movement feature a Fusee cone and chain, but it has a Verge escapement. Okay guys, I've had this watch for months now, trying to research how to service a Verge. I finally think I'm ready for this. I wasn't. Despite all the research and planning, nothing could have prepared me for what I had to deal with inside this relic. These really old antique pocket watches are incredibly thick, and you'll soon find out why. This watch comes in a sterling silver pear case. Pear meaning there's an outer case that clasps over the pocket watch itself, which has a hole in the back for a key. The outer case serves as a dust cover of sorts, but it also holds records of past services performed on the watch. Huh, Perth. So this watch traveled all the way to the land down under for service. It didn't. As a matter of fact, there's more than one Perth in the world, like this one, in Scotland. This watchmaker was the last shop to service the watch. They've been in Perth since 1832, and it's still family owned and operated to this day, which I personally find really cool. Written on the back, I have to assume is the owner of the watch at the time of the service. All sterling silver in the UK is required to be hallmarked. The Lion Passant is the standard mark for sterling silver. There were several assay offices in the UK, but the crowned leopard's head indicate the case was stamped at the London office prior to 1820. The date marks, specific to the London office, indicate it was stamped sometime in the year 1794. The bullseye crystal looks fine. It could be original. I don't know, maybe not. I'm not sure of that, but I plan on keeping it. The hole on the back allows the owner to insert a key to wind the movement counterclockwise. I think the hands are made of gold and appear to be original to the watch. The dial is absolutely flawless, which is a rarity on these Georgian-era watches. Time setting is achieved using a key on the center post. I'm just aligning the hands so it's more convenient to pry them off with these levers. Are these gold or polished brass? What do you think? The latch is a bit jammed. It should be sprung, but that isn't too hard to address. Oh, this is absolutely beautiful. Look at that engraved gilded movement. I've read in many cases it was women who carved the graceful patterns you see in these antique timepieces. There are a couple screws, but most of the movement is held together using brass pins. The Fusee chain is intact but is mostly wound onto the cone, meaning the movement is wound up and under tension. That wheel with the teeth pointing up is called the contrate wheel. J. Carlton of Liverpool produced this movement. I really hope I do right by you, Mr. Carlton. The movement itself is hinged into the inner case using a pin that will need to be pressed out. For this, I'm going to use a piece of blued steel stock mounted in a pin vise. Just sort of removing any burrs before I get started. Let's take a moment to appreciate the appearance of this movement. The elaborately engraved balance cock shields the fortunately intact Verge balance staff and wheel. Off to the side is the regulation adjuster, allowing the owner to fine-tune the timekeeping as seasons change or when oils begin to dry out. Looks like I'll need to make a new screw. The base of the balance cock is engraved with a rather mean-looking dude. Who are you supposed to be? Father Time? The dial is held onto the movement with these brass pins. Very interesting how there's sort of a brass alignment plate mounted under the enameled dial. As with most watches, the motion work consists of the hour wheel, minute wheel, and the cannon pinion. Notice these marks scribed by a compass or depthing tool. Since watchmaking was mainly a cottage industry, most parts being made by hand and basic tools, every movement needed to be designed uniquely to work with these parts on hand. Measuring and aligning like this was a way to account for the individual differences and inconsistencies of these parts. How do I let down the power of a fusee? Well, buckle up because this is a process that's not for the faint of heart. This here is the third wheel. I'm going to pull this out of the movement to release the power. But Chris, isn't that a click over there? It's not. In fact, this is the setup ratchet, and all it does is really just preload the mainspring for when there's no wind to the cone. There's only one way to properly let down a fusee, and that's by removing the third wheel. Those of you used to working on Swiss lever escapements, those with a pallet fork, may out of habit try to pull out the balance first, thinking you're just going to protect it. However, doing so on a verge will trigger a massive release of power uncontrollably. The verge staff is integral to the escapement itself and needs to remain installed until power is let down. So don't do that. When power is let down, the entire chain will be wound onto the barrel and there shouldn't be any chain left around the cone. The chain is wound onto the cone from the bottom to the top. The dynamics of the cone compensates for the fact that these old mainsprings lose power as they wind down. More on this later. Back to the task at hand. First, find a key that fits the winding square at the top of the fusee cone. Mount the key in something sturdy, like a bench vise. I'm using my trusty micrometer stand. Fit the movement over the key. Now I can prepare to remove the bridge plate from over the third wheel. Most of the bearings in this movement are brass bushings, just like clocks. I'll need to inspect them all and replace any that are worn. I'm giving the movement a slight counterclockwise twist to unload the train, which makes it safer and easier to lift out the wheel. So that's what nearly 2-century-old cobwebs look like. And I guess I don't know what else I was expecting. It's very important not to sneeze or do anything that would cause the movement to slip out of your hand. I'm holding back the strength of the main spring and I'm gradually allowing the movement to rotate about the key as the power is released. The chain is fully wound around the barrel and is simply hooked onto the cone. The chain remains taut thanks to that preload applied to the spring by the aforementioned setup ratchet. I can now remove the balance that's hidden under this beautifully engraved balance cock. Each one of these screws is unique, and you can easily tell how they were individually made and then slotted using basic hand tools. The balance cock has a capped bushing pressed into it for the balance staff to rotate. I can release the hairspring from the stud by uninstalling this brass pin. I can tell something doesn't look quite right about it. The coils seem a little close together for a verge, and the terminal curve isn't very concentric. This is what a verge balance staff looks like. It has two flags, or pallets, protruding from the center facing about 100 degrees apart. This one has a bit of pitting on the flags, but overall looks good. The teeth of the escape wheel push the pallets of the verge, causing the balance to swing. When the tooth passes the pallet, the tooth on the other side drops onto the opposite pallet. The process repeats over and over as the escape wheel is driven by the rest of the train of wheels. The regulator plate is screwed to the top plate. Underneath it is a small gear that's turned when the regulation dial is adjusted using a key. I just need to press out this brass pin in order to separate it for cleaning. The gear on the underside of the plate I just removed interacts with this track. So there's a slot on this track, or rack, where the hairspring is fed through. Moving the rack back and forth then changes the effective length of the hairspring, speeding up or slowing down the timekeeping. Before separating the plates, I still need to let down the preload of the main spring by releasing the setup ratchet. This will remove the tension from the chain, which will allow me to easily unhook it from the fusee cone. Check out this barrel and arbor hole. Ooh, look at that slop. This is way too much free play. I'm going to need to make a new bushing for this. I'm removing these brass pins that protrude through the posts, holding the two plates together. One of them is missing, but I plan on making new pins for all these anyway. This is the contrate wheel. The vertical teeth directly drive the escape wheel pinion. Well, that's disappointing. A broken tooth. Looks like there's another one over here. It's not as bad, but it is cracked and bent inward. I'll deal with these later. I'm just unhooking the chain from the cone and the barrel so these parts can be removed for cleaning. So, if a rodent rode a bicycle, it would have a chain about this size. Although this chain may look like a bicycle chain, the bicycle itself would not have been invented for at least another 20 years. I've heard that women and children primarily built these, and I can't imagine how long it took to make each one, under candlelight, and with the most basic of tools. I'm just removing the fusee cone and the center wheel so I can inspect them in case they have any damage, but they look fine to me. Oh, and in case you're wondering, this blade-looking thing on the top of the cone is part of the overwind protection. When the chain reaches the top of the cone, it presses on a lever that's mounted to the movement plate. The lever is then in the way of the blade of the cone, and then it basically just prevents it from winding any further, thereby saving the chain. This is where the chain was hooked. I always disassemble the fusee cones to clean and re-grease their internals. This one doesn't look too bad, but I don't really see much grease. The mainspring will not be replaced. Why is that? Well, I covered this in another video, but let's review exactly what a fusee is. So what exactly is a fusee-powered movement? It is a system employed by early timekeeping devices to deliver constant power to the train of wheels as a way to improve isochronism. The fusee fine-tunes the power delivery to account for the imperfections and variability in component manufacturing. The fusee itself is a conical-shaped pulley attached by a chain to the mainspring barrel and serves as the first wheel in the train. It's common to associate the fusee with early keywind pocket watches, but the system was actually in use long before timekeeping was portable. When the movement is fully wound up, the chain is wrapped completely around all layers of the fusee cone. The smaller diameter sections of the cone are employed when the mainspring is at its strongest. As the watch runs down, larger diameter sections of the cone release the chain, compensating for a decrease in power output of the mainspring. The cone itself is built specifically to work with the unique dynamics of the mainspring, so replacing the mainspring means modifying or replacing the cone as well. The chain is also extremely delicate, and snapping one of these while the movement is fully wound would be catastrophic, so the stakes are pretty high when working on one of these. Eventually, advancements in manufacturing rendered the fusee obsolete with the introduction of the going train, which allowed the mainspring and barrel to directly drive the train of wheels with reasonably consistent power delivery. So I plan on cleaning and reusing this mainspring. This is the escape wheel mounted between the potence and the counterpotence. In theory, there is some adjustability to control the depth of the teeth against the pallets of the verge staff, which have a drastic effect on timekeeping. Verge movements are notoriously inaccurate for several reasons, one of which is due to the teeth rounding off over time, thereby changing the effective depth relative to the verge staff. Apparently, you can resharpen them if courageous enough. These look... they're probably good enough. That's what you think. The case latch is sprung outward and will need to be cleaned and re-greased. I'm not quite sure why the spring screw was filed down. There's no harm leaving it here, and there isn't any advantage to removing it. I'm removing the overwinding protection, which consists of the spring and a lever that is fitted using another brass pin. The potence can be uninstalled by removing this screw, which will then free up the escape wheel. The counterpotence remains fixed to the plate. As you can see, the potence has holes for both the escape wheel and verge balance staff pivots. Some kind of solder job. I'm not sure if this was a repair or part of the original build. The counterpotence has an adjustable offset pivot point for the escape wheel arbor, which can be rotated to adjust the pinion depth to the contrate wheel, and slid in and out to adjust the end shake of the arbor. And here's the escape wheel itself, which is also sometimes known as the crown wheel. Now to figure out how to replace the bad teeth on this contrate wheel. You've seen me make new teeth before, but this is slightly trickier since they're not on the same plane as the wheel itself. Here goes nothing. But hey, the watch doesn't run, and if I screw it up, it's not like it'll perform any worse than when I started. Time to extract this broken tooth. You have to make some sort of a trapezoidal shape in the brass so the replacement piece fits in more securely. I'm using whatever I have at my disposal, including these tiny files. Okay, that will do, and the cutout is slightly flared at the bottom, which is what I was going for. You can find brass sheets of various thicknesses on Amazon pretty cheaply. I can make new wheel teeth for the rest of my life with this guy. Just cut out a little chip and file it, shape it, whatever, until it fits the slot. It should just stay there without falling out. Then it can be soldered in place. I'm trying something a little different this time. One of you recommended just taking a small piece of solder to the work rather than applying it directly from the spool. I think this worked out better and made less of a mess. It still required some cleanup though. Okay, now I'm filing it down to match the height of the other teeth. Oh, I get to repeat this process for the other tooth, but I'll spare you the pain of having to watch me do it twice. Once again, my slotting file is the hero of this step, but I won't be able to showcase my beautiful rounding up tool since it isn't designed for contrate wheels. Instead, I simply just filed the rounded profile by hand the best I could. Hopefully that will work, and there's the other tooth. This one came out a little nicer. I want to be absolutely sure the depthing and everything is good, so I temporarily reinstalled the escape wheel and cycled it around with the contrate wheel. Not done yet. The pivots are quite worn and could benefit from a little burnishing using the Jacot tool. Burnishing is a process I use quite often, and almost all the watches I repair have at least a couple pivots that could benefit from it. Basically, a hardened piece of steel with a fine file surface is worked over the pivot. The pressure of doing this basically smooths over imperfections, compressing the steel of the pivot, work hardening it as well in the process. The surface will end up looking more polished as well, and the whole process doesn't really remove much material at all, though the overall diameter afterwards can be smaller due to the compression, so just be aware of that. There are a few pivots that could benefit from this, so I'll just go ahead and knock them all out while I have the tool set up. That looks considerably better. Let's do the barrel arbor next, because why the heck not? Is that absolutely necessary? No, honestly, it's probably not going to be a game changer, performance-wise, considering old Verges have so many other things going against them. Here's a tip. Scrub all the bearings with a piece of pegwood to break up any old oil stuck to the inner surfaces. Trust me on this one. If you're a beginner and you're looking for a cheap way to improve your cleaning game, pegwood, especially if you don't feel like investing a small fortune in a cleaning machine. Tip number 2. For non-jewel bearings, I like to use a smoothing broach to sort of burnish the inner surfaces of the holes. Don't go too crazy with it though, you obviously don't want to expand the size of the hole. I'm just doing what I can here to remove the surface corrosion from the balance wheel. I'll need to use my sights tool to remount the barrel arbor hole in order to prepare it for the bushing I'm about to make. The general idea is that the hole is reamed to 1/1000th of a millimeter smaller than the bushing itself, so the bushing can then be friction fit into the plate. That would be the outer diameter. The inner diameter hole is figured by measuring the size of the arbor and adding a couple hundredths of a millimeter. The thickness of the bushing is equal to the size of the plate plus a little extra to minimize the excessive end shake of the barrel. My trusty watchmaker's lathe has gotten me out of more than one bind. When you can make your own parts, repairs suddenly become a lot more in reach than ever before. I'm now just turning down the raw bar stock to the external diameter needed for a good friction fit into the hole I reamed into the plate. And now I'm just facing off the work and then turning in a center point that will be used for the next step. I don't have an elaborate tailstock drilling setup. All of my drilling for all my repairs is done by hand using a pin vise holding the drill bit. And I chose a drill bit that's just slightly larger than the barrel arbor itself. This blue paint I'm using is called layout fluid and is handy when trying to mark up the work, like when I need to scribe a line representing the approximate thickness needed for the part. Here's the bushing after it's been cut from the rod, and it's ready to be pressed into the plate. With the bushing pressed in, I can check it with the barrel installed to ensure the side shake issue has been resolved. The original watchmaker used the same thread pitch on all the plate screws, so I'm using this one for reference. I got lucky and found a thread pitch on this screw plate that's a good match. This isn't the first time you've seen me make a screw, but for those of you just tuning in, I use my watchmaker's lathe to make screws out of steel rods. After facing off the end, I turn down the shank to the right size. Then with a little cutting oil, I can apply the threads onto the shank using a screw plate while supporting it evenly with the tailstock. Being able to make basic parts is a requirement to working on really old watches. You can't exactly walk into a store and buy a replacement part, or even find a donor movement online for something as old as this. And now I'm shaping the head into a taper in order to fit the countersunk hole within the plate. With the screw head slotted, I'm trying to finish off the top by polishing it using my staking set and some emery paper. This is certainly the poor man's way of doing it, as there are purpose-built tools for this, though I may make my own in the future. I'm pretty happy with that finish. And motivated by the result, I'll see what I can do about the other screws that look pretty chewed up. Maybe I can clean up the slots a bit using a file. And after a quick polish, not too bad. I went ahead and did the same for the others. Even the balance cock screw got some love. Of course, I like the blued look they originally had, so I'll go ahead and heat treat each one to restore the finish. Nice. These pocket watch mainspring winders haven't made an appearance in a while. They work fundamentally the same as the wristwatch spring winders you usually see. The arbor of the winder has to hook the inner loop of the mainspring, and then it can be wound into the holder. Of course, pocket watch mainsprings have all sorts of different tail ends, which add to the fun. I'm using HP 1300 for lubrication here, and for most of the other higher friction surfaces throughout the movement. Ugh, love that sound. And now the arbor and the lid. For some reason, a common mistake I still make is sometimes I install the arbor upside down. I just need to remember to sanity check the face of the hook against the direction of the spring. You can also test out the spring hooks the arbor by turning it with the key. The internals of a fusee cone include a ratcheting click and what appears like a hand-carved ratchet on the lid. This deserves some Mobius 9504 grease to limit any future wear. And then the collar and pin can be fitted back on. I'm lubricating the potents and counterpotents now, where the crown wheel will be fitted. There's something that only became apparent to me when editing the first half of this video, You'll soon find out what it is, but for now I'll continue. Now I'm reinstalling the overwind protection. I've been asked a few times how to replace a broken fusee chain, as in what to look for. Well, there are only a couple metrics that are important since it's not like it has to fit over cogs like on a bicycle. First, it needs to be the right thickness to fit around the steps of the cone. Second, and equally as important, it must be long enough to engage the overwind protection when fully wound. If not, then the chain itself is the limiting factor when you reach the end of the wind. Any extra stress on the chain will of course cause it to break. And of course, a shorter chain also means a lower power reserve. I'm making sure to grease the case latch really good and to ensure it moves freely and doesn't bind up. I now proceed with the train of wheels. The fusee cone is actually the first wheel in the train, which drives the center wheel, which is the second wheel of the train. The others will be installed later on. There's the mainspring barrel, and I'm lubricating the arbors as I get ready to lower the top plate, but at this point I'm unsure whether the contrate wheel could fit through the little third wheel window. I later learned it can, but I went ahead and just sat it here anyway just in case. The last thing I really want to do is have to make any more teeth. Onto the regulator assembly, I had already refitted the adjuster gear and display index to the plate. I'm using 9504 grease to help reduce wear over time. The freshly blued screws, including the new one, are used to install the assembly to the top plate. This is a very neat regulator design, though it's a bit clunky. As you saw before, the hairspring is pinned here, but then it's fed through this slot. And after this slot, the hairspring just coils around and around until it meets the collet on the center of the staff. This regulator can move back and forth, making the hairspring effectively shorter, to speed up the watch, or longer, to slow down the watch. The numbers scribed onto the wheel here give a reference by how much the timekeeping would change when it's turned. I suspect the hairspring was replaced at some point, and due to the wear of the escape wheel and how that can greatly impact timekeeping, I'm not certain these numbers can really be counted on. So again, they're really just there for reference. I love the hand with the finger pointing to the current set point, rather than simply a mark or an arrow. Watchmakers of this era, and for a good while afterwards, took so much pride in their work. The lower bearing of the contrate wheel is blocked by the regulator plate, so I'm sneaking the oil in from this side before I slide the wheel into place. And the same goes for the third wheel hole. I'm carefully lowering the third wheel back into place before the bridge is reinstalled. As I'm doing this, I'm just wondering, how do you think watchmakers from the 1700s would react if they knew their timepieces would continue to be worked on in the 2000s? Crazy. I'm just lubricating the pivots after having installed the third and fourth wheel bridge. What I'm doing now is just making several new brass pins in order to secure the movement together. I could reuse some of the pins that came with it, but over time the brass pins compress and wear down and then therefore lose their effectiveness. It's not hard to make new ones when needed. It may take longer, but you can even do this with a pin vise and a file if you don't own a lathe. It's of course very important they're tight. The last thing you want is for one of them to fall out and jam something up. Before going any further, I just want to quickly check the train for freedom of movement. Seems pretty smooth. I'm lubricating the chain with some light synthetic oil. I don't want a dripping of oil, so I'm just absorbing the excess by cycling it through some watch paper. There really isn't an exact science to this part. So now I'm just feeding the chain around behind the pillar so I can first hook the end onto the mainspring barrel. It's a little bit fiddly, but I'm trying my best not to introduce any kinks. Now I can just wind it onto the barrel to take up the slack until I can hook the other end onto the fusee cone. Again, super fiddly here, and sometimes the chain unhooks itself from the barrel and you have to start all over again. So I learned it helps to put a little bit of pressure on the chain like I'm doing with my finger to help keep it tight. Only took me 19 tries to get it right. Okay, now it's hooked onto the cone, but the chain is still quite loose until I can get some preload onto the main spring. To do this, I use this setup ratchet and click. Standard practice is to set it up by 3/4 of a turn. Aside from preloading the spring, it essentially eliminates the section of the spring wind that would provide the weakest of timekeeping. Again, make sure the chain isn't kinked anywhere and it isn't overlapping itself in any section. I'm using a little Mobius 9010 on the staff pivots, but these aren't jeweled bearings, so I debated whether HP 1300 would have been a more appropriate choice. Just gingerly feeding the hairspring through the stud, and I also need to place it between the pins of the regulator. Remember guys, fusees are wound counterclockwise. I don't believe it actually runs. Oh, so happy it's ticking. Cross positions too. Oh, so good. The new teeth aren't jamming up either. I don't really know what to expect from one of these. Seems to be pulsating a bit, speeding up, slowing down. I don't know, I guess this is okay. It wasn't. I can see the light at the end of the tunnel. So glad it's almost finished. It's not, and despite my wishful thinking, that doesn't sound... maybe oils just need to settle in? I really had no choice but to pull it all apart again and figure out where I went wrong. As it turned out, I missed the fact that the crown wheel was loose on its arbor, and I'm disappointed in myself for not catching this sooner, as it was quite evident in some of the earlier footage that showed it wasn't sitting on there straight. I decided against doing this earlier, but I'm going to take a stab at sharpening the teeth of this wheel to see if I can boost performance a bit. This is quite tedious. I mean, most watchmaking work is tedious, but this is the worst kind of tedious. But in the end, I'm glad I did it, and you can really see the difference compared to how it looked before. The next step is to close up the hole on the wheel so it sits a lot more snugly on its arbor. Just a few gentle taps from the dome-faced punch in the staking set gets it done. And then the wheel can be tapped onto the top of the pinion. Another issue I found is that the counterpotence came loose. Oh no. Seems like there was some kind of shim inserted here as a way to adjust the end shake of the arbor. Perhaps that weakened during the cleaning process. In any case, I'm going to see if I can tighten this up as well and avoid using any kind of shims. The runner still needs to be adjustable since the pivot hole is intentionally offset as a way to adjust the depth of the teeth. Once again, I'm using my domed face punch to slightly close up the hole while balancing the bridge alongside my bench block. With the counterponents reinstalled, I mounted the escape wheel again and observed how it interacted with the verge staff. Since sharpening the teeth removed some material, the depth against the pallets is really small now. That would have a side effect of very low amplitude and a higher rate as a result because the crown wheel teeth just sort of skim past the flags. The goal is to have the teeth approach the arbor of the verge staff as closely as possible to the center without binding up. The only way I saw how to achieve this was by filing down the plate that has the bearing hole for the escape wheel arbor. The more I file, the closer it will sit toward the verge staff, and I can make up the excess end shake by pushing in the counterpotents you saw me work on earlier. This is much better. The verge staff has a nice strong reaction when each tooth interacts with the flags. Let's see now how that runs. Adjustment number 1877. Keeping time to within 24 minutes a day. Can we get better than that? Who knows? Sort of a time hop here, but I iteratively recoiled the hairspring, sizing it to the appropriate length. Given the new depth of the escape wheel teeth, and the spacing is now much more even and concentric than it was before, and better reflects what you'd typically see in a Verge watch.
3 weeks later.
Finally happy with the timekeeping, I decided to test it against a known good reference since time graphers don't work with Verge escapements. Overall, the movement is keeping time to within 3 minutes per day. Not bad for a pocket watch from the 1700s. Imagine when this watch was made, King George III was still the King of Great Britain, where they were still in the upswing of the Industrial Revolution. America had won its independence only 11 years earlier. The French Revolution was well underway. It's an amazing feeling working on something so beautiful, yet so old, but still functions as it should. And honestly, it's kind of strange to think about how one day we'll all be gone from this earth, and 200 years later, maybe someone else will be critiquing my amateur repairs and having their, nanobots broadcasting it to the metaverse or whatever they have then. I'm freshening up the hands, but because I think they're gold, I'm obviously not going to go crazy with it. I want to give a special shout out to Nathan Daz, who kept me grounded with his practical advice while I struggled my way through some parts of this repair. I encourage you to check out his business, a link to which I put in the description. This was a humbling experience for sure, but fortunately it had a happy ending. I hope you all learned something from this video today, but if not, and more importantly, I hope you at least found it enjoyable to follow along with me. Thanks for fixing watches with me today, and perhaps I'll see you in the next one.